investment casting, which is also known as lost wax casting, some people would argue is 6,000 years old. Some of the oldest castings have been found in places in northwest Pakistan. They've been found in Iraq. Some of these castings have been found in China. They are these bronze figurines that were made using the lost wax process, where you first make a copy of the part that you want to make in metal. You make a copy of that in wax, and then you create a ceramic shell around the wax copy of the part. Then you melt the wax out, and then you fire the ceramic shell to a hard object which has an internal cavity into which liquid metal gets poured and solidified to then yield this casting. That 6,000-year-old process today is used to make the most advanced, most high-performance components that are made by casting anywhere in the world, such as the first-stage high-pressure turbine blades that go into aircraft engines. Today's state-of-the-art process for making these components is a 12-step process. The first 7 steps are the steps that are required to create a ceramic shell which is now ready to receive liquid metal to be poured in a casting furnace and then allowed to solidify. Those first 7 steps, which are necessary to make the ceramic shell, are the longest lead time, and they account for 90% of all the sources of scrap that occur in this process. They also can take somewhere between 33 to 50% of the total manufacturing cost of making the part. So for example, if you're an aircraft engine manufacturer, or you're a gas turbine manufacturer, or you're even a manufacturer that's making components for pumps and impellers for handling fluids in petrochemical plants, or wherever there are liquids and fluids being conveyed over long pipelines, you need to make these parts with investment casting. If you start with a new design, to get your first casting can take anywhere from 18 months to 2 years before you can have an acceptable part that can be subjected to testing and validation. So you're dealing with extremely long lead times, and on top of that, there's the upfront cost of making tooling that you need in order to shape the wax into the right shape. So there's an upfront investment cost in tooling, and the tooling never works right the first time. So then you have to send the tools back to the tool and die making shop and get them readjusted. They have to be reworked, and that adds more time to the overall process. So what does DDM do? We come in and we eliminate all those 7 steps, and we replace those 7 steps with one step that directly prints the ceramic shell. That is the outcome of the 7 steps in the traditional process. We have a 3D printing technology which allows us to print in very thin, fine layers of 100 microns each, which is close to the diameter of human hair. That's how thin it is. And we print these layers one at a time using a proprietary material that we've developed in our machines, which is also our proprietary design. And by doing that, we eliminate the upfront investment that's required in tooling, all the tooling costs, all the lead time to get the tooling made, and we take out all these other steps that each of which can contribute to a defect or a scrap in the part. We eliminate all of those and replace them with a single step, which gives us a 3D printed ceramic shell, and it gets then post-processed and fired in a furnace in exactly the same way as how it's done in the foundries today to make it ready for metal casting. So in the end, what is the outcome? 10 times faster at half the cost. That's what we do to the overall process of making casting. So what would take 2 years to make can now be done in 6 to 10 weeks. That is dramatic acceleration. It allows companies to use this technology not only to make prototypes and be able to dramatically accelerate their design through prototyping cycle until the design is frozen to a production design, but then the same technology, our lamp technology, can be used then to make the actual production part in production quantities.